So if you're one of these students that really like to sort of like listen and you can't like write and think and hear and all that at the same time, no problem. It's all recorded for you every day, and it will be on our Moodle site. So let's come back to this. So this first one, yeah, you say, well, it's a formula. Well, guess what? A model is a formula or an equation from mathematics. And think about like little paper airplanes or model cars or whatever. They try to represent, another like larger or phenomenon. So all a model in mathematics is just a formula or an equation that represents a relationship between particular entities like length, width, and area. So that's a true statement. 2, I think we had agreement on 2, yes. So what do you think, what other fields do you think models can be used in other than science? Math, yes. What are some of the areas that you're interested in studying? Carpentry, absolutely. Does anybody know a model that carpenters use a lot without maybe even knowing the name for it? Yeah, A squared, B squared, C squared. What's that one called? Pythagorean theorem, right. What about if you're a roofer? What do you think you use a lot? If you're a roofer. Slope, right. They call it pitch of the roof, right? Okay, what other fields do you think maybe models could be used in? Carpentry, science. Anybody in here in engineering? Absolutely. Engineering, environmental science, right? Business, right? All the models that people have for trying to predict what their revenues are and their profits and all that stuff. Okay, so models are used in just about every particular field you can imagine. So now we're down to number 3, which there was 1 true, 2 trues, and 3 falses. So number 3 was another one. The square root of 2 cannot be represented on the real number line. So who wants to argue that one as a true or a false? An agreement or a disagreement? Square root of 2. Yep.
I think a real number is positive, so that would have to be positive numbers.
You think a real number line is just positive numbers? Is that what you're saying?
Oh, no,
that's all right. I'm just trying to make sure I hear you right.
Yes, I think it's above 0.
It's definitely above 0. Okay. What's a real number line look like anyway? Does anybody know? Yeah, go ahead. I didn't catch your name because, Julie. All whole numbers above 0. Okay, so here's 0. And is 0 a whole number? Okay, so you can write that one down and make sure you figure that out by reading your textbook tonight before Friday's class. I'll ask you this at the beginning of Friday, and if I forget, you're going to remind me, right? Okay. All right, so all the whole numbers above 0, what does she mean by the whole numbers? Oh, okay, those nice numbers, right? So we call these things the natural numbers, or counting numbers, right? Because when you were little and you were trying to show off that you could count, you didn't start with 0, right? Did anybody here say 0, 1, 2, 3? No, right? Am I right? Look at hey. Yeah, you said, oh, I'm showing off 1, 2, 3, right? ABC, right? All right. Natural number. So then, is that a whole number? And what's the difference? All right. What other numbers are there on here? Yeah, go ahead. There's numbers before that. You mean over here? Yep, forever in both directions. So every one of these counting numbers has a counterpart on the other side. We call them opposites, right? And they're the same distance from 0, yes? So these two numbers have the same absolute value. Because they're the same distance from 0, they're both 1. Okay? So absolute value is a concept that asks you, what's my distance from 0? And that distance will always be positive. So anything that has this around it will come out positive. Right? So we're still dealing with the square root of 2. Yep. Can you change your answer? Absolutely. Okay, I'm just asking if it can be, okay, are only whole numbers represented on a real number line? What else can be there, Haley? 1.5 or 1.5 or 3/2. What about 2/3, 0.1, 0.000000000009? What kind of numbers are those? Decimals, and what kind of numbers are decimals? Fractions, and what kind of numbers are fractions? Huh? Mixed, yep, you have mixed numbers. Some fractions are mixed numbers like that. Some fractions are proper like that. Some fractions are repeating like that. But they're all can be represented by the ratio of two numbers. Ratio, does that ring any bells? What kind of numbers those are? Rational, right. So rational numbers. So now you've got all the rational numbers on both sides. What's the square root of 2? Yeah, point, I don't know if it's 0.2, but it's somewhere between 1 and 2, because 1 square is 1 and 2 square is 4, and 2 is between them. So it's 1 point something. Does it stop? Try putting it on your calculators for those of you who have calculators. What do you get? Square root of 2. Depending on how many fields your calculator has. 1.414. Must keep going. Yeah, and if you had a calculator, a computer, this would go on forever and ever. It never stops. There's no two numbers that you can divide that represents the square root of 2. Okay? Poor Pythagoras almost got killed for that discovery. I'm serious. Okay? It's irrational. That's what we call that number. Irrational. It can't be represented like this. You put all those numbers together with all the rationals, and you get every single number on this real number line. So square root of 2 is a real number. It's also called irrational, and it does have a home on there. And how can you find that home? You could take, if you wanted to use Pythagorean theorem, and you took something that was 1, say this way, 1 by 1 or 1 by 1, and then you built the hypotenuse to join them, that would give you the distance called the square root of 2. Okay? But anyway, that's just a warm-up for today. All right? Now, what's my purpose for doing this? I've been thinking a lot about this class all summer, as a matter of fact, and I've been thinking a lot about these anticipation guides. And as you can see, it says, after reading the section, and I know that some of you are sitting there saying, I've never read a math book in my life, and I'm not going to start. Okay, maybe some of you are saying that. I hope most of you are not saying that. Because what you need to realize, this is a college algebra class. Okay, some of you have had math classes at GCC prior to this one. They were not college level courses. And this is not a high school algebra class. And let me tell you the difference. In high school, you usually have class 5 days a week. The teacher gives you everything you need, and you go home and you just do, if you were motivated, you just do problems and you go back to class. Sort of the teacher does everything for you. And in a lot of ways, it's not really, giving you the right sort of tools for coming into college. This class, I have a responsibility to you, and as you can see with these packets right here, hopefully on Monday you'll get the rest of the packet up to test 1. But these are the lecture notes for today's class and Friday's class. And you have a responsibility. If you turn to the very end of lecture 1, which is about 3 pages in, it says homework, right? Homework. Everybody found that page? Let me see if I can. All right, I'll quickly get there. Here we go, homework, okay? So the very first thing you see is prior to working homework problems, read and take notes on Section P1, algebraic expressions, mathematical models, and real numbers. Now, I didn't intend to do this today. I didn't intend to do anything about numbers. I was hoping that you would do that, okay? But given that I started off with the anticipation guide, it was kind of a nice way to start. So if you look at the beginning of this, it will say mathematical models, algebraic expressions, self-review, real numbers, self-review. That means in this packet, I'm not covering those two ideas explicitly. You need to read about that and take notes because this is a prerequisite chapter. These are supposed to be the prerequisite knowledge you have coming in. But I know, I've been teaching this course a long time. Hey, for some of you, this is just too foggy. So we will cover most of it, but you will have throughout the prerequisite chapter some areas that you are responsible for. I gave you homework questions that deals with real numbers and algebraic expressions, but your responsibility, this has to be a daily responsibility for this class. You need to read the textbook and take some notes, okay? Because I can't do everything for you, and I'm not supposed to do everything for you. You have to do some of this stuff for yourself. However, the support here is unbelievable. I'm here every Monday, Wednesday, Friday, Tuesday, Thursday. We got the math studio. We've got peer tutoring. Lots of support for you, okay? But the main idea I want you to understand is if you have some old habits like, you know, coming to class, kind of listening, not doing much in between class, and then coming back to the next class, not doing much in between class, you know, and then, oh yeah, we're having a quiz on Friday, so maybe I'll take a look at a few problems. It probably won't work or serve you well, okay? I'm just trying to give you a sense that it's sort of like a daily commitment, okay? It's a 4-credit college math class. Now, I'm not trying to scare you or intimidate you in any way, believe me. I'm just trying to give you a sense of you really have to be sort of on top of stuff. Time management, right? If you're one of these students that have troubles organizing your time, please come see me. I'll help you out. I've done this with lots of students, okay? I have one of my daughters, getting her up to go to school in the morning is like a nightmare because she just can't get up and she can't be on time. So when she now is taking a bus to school, she's already missed it 2 out of 5 days. So I understand, believe me. So I am not going to go over the syllabus per se. I think one of the most boring things a teacher can do is sit here and tell you about what is on that syllabus when you're very capable of reading it. However, on your homework, you see that I'm asking you to read the syllabus and then answer these 3 questions. Okay, the 3 questions are, what questions do you still have after reading the syllabus and reviewing the schedule? How does the syllabus address your strengths as a learner? And what did you read in the syllabus you wish was not there? Okay, that's always kind of a fun one to ask and get the responses to. And I would like these responses back from you on Monday. Now, if you happen to do them before Monday, this little folder at everybody's table right here is sort of how we pass stuff back and forth to each other, okay? So when you come in Friday, if you've got them done, throw them in here with your name on them. I will look it over and I will put it back in here for you, okay? I usually record questions and different comments every single year, every single class, and then we discuss them later on. Now, if you haven't already done so, just put your name on here and then put a little check for 9-3 that you're here today, okay? Now, this doesn't mean you're cemented in the seat that you're in right now. If you want to switch tables, no problem. Okay, if you hear a couple of classes and you just feel like, oh, you realize that you've made friends with someone outside or, you've been working with someone in the studio and you want to switch tables, it's no problem as long as there's space. We can't have more than 5 at each table by code, right? Fire code. So you can only have 25 in here. So please don't feel like you're absolutely glued to those seats. Ian Winokur, one of my colleagues, did this up because some of you are new to GCC. This tells you how to log into just about everything you could possibly want to log into. I think many of you may be aware that your new student emails now go to Google, the Google account. So that's going to give you some extra flexibility. So some of you may not need this handout, which is fine, but I wanted to provide it for you. Okay. So there are one or two things on the syllabus that I do want to cover. Again, I know that you can read all of this, but there tends to sometimes be questions about this. The textbook and materials, you have three options with the textbook. Sonia, can I grab yours? Sonia got what the publishers called book a la carte, which is it's 3-hole punch, and it's, you know, pages like this. It's not bounded and it's not hardcover. This with the access code, I think, was what, about 136, something like that. Okay, sort of the middle of the line. The hardcover book Brendan has. Okay, it's not necessary to buy a hardcover book, but if you prefer a book, that's the top of the line, the big hardcover book like that. Brendan knew he'd tear apart those soft pages, so he wanted to have something. And then some of you may be very fine with doing everything online with the e-textbook, so you just buy the access kit and the code, and you're all set. Okay, so yeah.
So it's the textbook, the access code is required.
Yes.
If I'm generally more comfortable using a physical textbook,
Yep.
do I still need to get the...
Yes, to do your homework. All homework's going to be on My Math Life, right? Yep. All your homework will be done online and graded online. Yeah. Okay. The other requirement that you need for this class is a TI-83 or an 84 calculator. We do have a rental program. I started way back in the 80s, late 80s, believe it or not, maybe late 80s, early 90s. And this rental program allows you to rent a calculator at a cheaper price. So if you don't think you'll be needing it as you move on, then that may be an option for you. Okay, but you will need a graphing calculator. We will be using it almost immediately. Okay, so if you have any questions on that, please see me. It's right here on your handout. Okay, it's right. I have everything written down, believe me. So calculators, yep. You don't need the hardcover, no. So if you want, and I know that the bookstore was sort of handing those out, you could have physically no text, it's all online. I will sometimes have stuff, but whatever I do, I'll put it here. Believe me, I wish we had at least one person at a table had a textbook, because then I'd do more of the stuff with the anticipation, but I know now that some of you are doing stuff online. So any other questions on the textbook or the calculator? Now, if you use other calculators other than the TIs, all my materials are in the book, and also the book is written for the TI, so we may have to sort of like do some problem solving, like if you have a Hewlett Packard or something like that, but we'll find our way. And again, I just want you to realize that I'm in the math studio Monday, Wednesday, Friday. These are my times, these are my office hours, but also see by appointment. I am here 5 days a week. I practically live here. So if these times don't work for you, we can always make some other times to get together. Okay. Again, I'm not going to go through all this other stuff here, but I do want to just cover this right here. This might be a little different. Generally, at the start of each class, I ask that you put a question on the board that you have from your reading, your class notes, or homework. Okay, so when you come in, and that's why when I got a chance to meet some of you earlier today, like between 8 and 8:30, I said, yeah, if you could get here 8:30 to 8:40, is I'd like you to sort of come in, and it could just be a general question, it could be a specific question, it could be something that's like been plaguing you, maybe the farmer's problem, I don't know. Just put it on the board, and then someone might come in from your table and you could talk about it. But anyway, sort of like the 8:30 to 8:40 time to sort of be looking at what are your questions? Either something that maybe came up in the book, the textbook, that you didn't understand and we didn't cover in class, okay? But basically, that's what I want you to do during that time. That gives me a sense of what remains unclear to you. So as I come in, and I'll always be here, well, I'll always be here early, I can kind of look around and see, you know, what's happening. I can come up and talk with you, and I can work with you on stuff. Okay, but remember the studio time, 8 to 8:30 is optional. You don't have to go there. We created that for you. It's to help support you in the learning of mathematics. Jen Burrow will be there at 8:10 every day. And hopefully on Friday, we'll have little studio bookmarks to hand out to you so you can have, they're great to use as bookmarks, but it has a schedule when the teachers will be in there. Okay, I want to skip all this stuff. I think please read this stuff about cell phones. Nothing gets my water boiling more than people sitting there looking at. I will ask you to leave the class if I see your cell phones out. Okay, all the tech support. Methods of evaluation. Okay, I'll quickly go through this. All your homework's done on my math lab online. You have 1 week. So let's suppose we started class Monday instead of today. The homework for Monday, the homework for today, and the homework for Friday will be due a week from Wednesday. Homework is generally due every Wednesday of the next week. So next week's work, next Monday, Wednesday, Friday, will be due the next Wednesday. However, I suggest that you don't wait a week to do your homework. But I build this in because, look, you have families, you have jobs, you're trying to go to school, you have life, right? You need some flexibility. So I try to build in flexibility, but I encourage you to at least try to do a little bit of the homework after each class. And then you can sort of scramble towards the end if you need to and get it all done for next Wednesday. All right? Any questions on that? Generally do the next Wednesday. There'll be exceptions right around the test. Sometimes you have like one extra assignment that's due that Wednesday, but generally it's the next Wednesday. All right? And again, use this as, some of you already have your habits established, so that's not going to be a big deal. If you don't get it all done on time, there's a 10% penalty for the remaining portion each day. And I've explained that in here. So if you got, say, 10 out of 20 points done, and then you finish it the very next day, then you get 9 out of the remaining 10. It's just a 10% penalty. All right, you can read about projects, quizzes, tests, finals, all that stuff in the makeup policy. Now, this is the part that might be different if you've never taken a class. Well, actually, I don't think anyone does this except for me in the classes below 107. I give you options for being graded. You can take the test-heavy option, which means zippo for homework. But you say, hey, I do the problems I want to do. I know what I'm doing. I don't mind tests. I don't mind being test-heavy. Other people are like, oh, I can't do tests and quizzes, but I'm really good every single day doing my homework and working really hard. Then you can do the test light option where your homework counts 20%. Okay, so you don't have to make up your mind right now. If you want to see how it goes, I would suggest everybody starts off doing homework, and then you can see whether after your first exam, then you can let me know which of these you want. Okay, so you don't have to make up your mind now. You probably already know what you want to do. Remind me your name? Eric, yeah. You will inform me of your choice on the class after I return the first exam. So that will be class 11. You will tell me on class 11, okay? Which is when? When is class 11? Well, on your syllabus, the back of your syllabus, you have your schedule for the entire semester already done. So here you go. Right? Class 11 is when? 9/27 is the test. Oh, sorry, you tell me on class 12, which is September 30th. So you have until then to think about which of these you want. Okay? Is it absolutely in stone, like if at the end of the semester you're like, can I change it? I might consider it. Okay? It's not absolutely in stone. It's just your way of deciding how you sort of want to operate in the classroom. Okay? Now, all the instructions for you to get on My Math Lab is right here. Okay? All paid, step by step. And the main thing you need is your course ID, and that's number 3. So it says Kavanaugh 92714. That's your course ID. Okay? And so that's all you need, really. Everything is pretty clear. You go into this website, you click, you put in your name, you put in your course ID, and then you get all set up. Now, I would really encourage you to put aside a half an hour and explore My Math Lab because there's so much available to you. There's incredible videos, There's lots of extra problems. There's a lot available to you as students. Okay, so it's like another whole sort of like huge resource available other than what you can get, face to face and physically at the college. It's really a great program. Okay, that's about all I want to talk about today. Any other questions before we start class? Yeah, Sonia?
I use my math lab before,
Yeah.
and for the class that I had, it used to give gave us the option, like if you need help with a certain problem,
Yeah.
if you like minutes,
Yeah.
and you also had like cheat and stuff.
I think we have all that checked off. Yeah, prior to this semester, I don't know how long have I been teaching 107. I came back to faculty in 2003. I was in administration, and we were using the book Stewart, and so we used it for 10 years. So all these lecture notes I had these lecture notes down, 42 lecture notes down, edited, and then we decided to change books for this year. So I am rewriting all of 42 of these. I'm like, what's wrong with me? But anyway, these things. So I'm rewriting these. So, if you notice any typos, let me know. If you're like one of those like great English people that see every little, let me know, because I'll go and change it right after class, okay? So I believe when Caitlin and I set up my math lab, we had been using a program called WebAssign. My first time using my math lab, so I've been trying to get used to it and thinking of, from an instructor's point of view, how you set everything up. But I'm pretty sure we checked all those things off in the little box for every homework assignment. Yeah, right. So if you see anything that you're familiar with that's not there, just let me know, Sonia. Okay, call me, send me an email, and we'll check it out. Okay, because like I say, it's new territory for me. So Caitlin's usually the technology genius of the pairing. So. Okay. Anything else before we go into today's class, even though we've already had a little class over here? Anything else on your mind? The book, the calculator, how class is conducted, any concerns? The other thing I wanted to just mention is I've been very intrigued by a woman named Susan Cain. Anybody heard of those things called TED Talks? Yeah. All right. Well, she has a book called Quiet with this long subtitle. And she's done a TED Talk. It's very interesting if you haven't seen it. And I've watched the talk 3 or 4 times, and I have her book. And it's about, and one of the things that really struck me is her whole her whole thesis is about being introverted in an extroverted world. And she talks a lot about how education, everything is done in groups. And if you look at how we've set up the tables, I have to say I am sort of responsible for this. I hounded the administration back in the late 80s to get trapezoidal tables because we wanted to promote communication in the classroom. But what I realized when I saw this TED Talk last year, and I've changed my syllabus, is that some people don't like to talk to someone else. They like to think for themselves. They don't want to, maybe, remind me your name. Maybe Jonah doesn't want to talk to anybody here. And you know what? That's fine. If you prefer not to do, when it's time to do group exercises, you just want to work on your own, you don't want to confer with anybody, doesn't mean someone's being snobby or anything. It just means that's their preferred way of learning. So I've changed my syllabus that even though this room reflects, and I hope that we can sort of collaborate, if that's not your style, that's cool. All right, so I don't want you to feel like you're being forced into any kind of learning style that you're not feeling comfortable with. Just let me know, because I can be a little like, oh, come on, let's do this together. And you're like, cool it, Kavanaugh. Okay, that's fine. All right. So I just wanted to mention that. So I think we're all set to go. I talked about the self-review part. So here we go. Models. Well, before we get there, someone want to read this first sentence for me under mathematical models? Eric.
Common refrain heard when teaching mathematics is, when are we ever going to use math in the world? The answer is now.
Yep, okay, so let's go. We're going to use it right now. So I want you to take a look at this bar graph. This bar graph shows the average cost of tuition and fees at public 4-year colleges in the United States from 2000 to 2010, and it's adjusted for inflation. So the first thing I want you to do is spend a few minutes analyzing that bar graph by yourself, nice and quiet. Write a few observations about the data presented, and then compare your observations with your neighbors if that's okay. If it isn't, no problem. Yep, Brendan?
I said that after 2001, the slope increased.
After 2001, the slope increased. Okay, that's increased. Okay. And what is the slope measuring here? What is it measuring in terms of this problem? The change in what two variables? Yeah, and what's y and x here?
Y is
Yeah, and what are they according to this?
Y is tuition. X is
Right. So the slope here is the change in the cost, right? It's the change in the cost over the change in time, right? So he's saying that after 2001, that increase got steeper, right? What else do people notice? And notice I use that little triangle. That means change in. That's the Greek letter called delta. Yeah?
Between 2003 and 2004.
Okay, so between 2003 and 2004 was the largest increase. I wonder what was happening back then. Okay. And did you actually calculate what that increase was? $613, a jump in 1 year, okay? And Logan, I noticed you had an interesting little sentence there on your paper. Sorry I peeked. Yeah, he said it looks like this could be linear. In other words, if we had a dot right here in the center of each of these, right? You could probably take a ruler and represent, not exactly a straight line, right? There's no straight line that would go through all those points, but you could probably fit some type of line that came close to all of those. So Logan says the data appears to be linear. Okay. Anybody want to say something else about that appearance of that data? Another shape that might fit it? Other than a straight line? Really gradual curve, like maybe something like a parabola, like a quadratic equation, maybe. We'll look at that in class 4. Oops, I kind of went a little crazy with my curve there. I didn't mean to dip down so far. Okay. Now I want to point out this is from your book, and the reason I wanted this is there's a couple of things here I wanted to point out about graphs. And one thing is to notice is that every graph, like if we have a project, should always have a title. Your axes should always be labeled. Did I spell that right? Label axes, yeah. You should always have a clear scale on each axis. On each axis. Okay, and then I wanted to point out this little thing right here. See this little kind of, it looks like this on the y-axis? What does that represent? Yeah? 3,000? Yeah. Right, so what's below 3,000? There's nothing there, right? And where should we start? 0. So in other words, there's a break in the axes here. It's not starting at 0, and that's because this graph, it would be like you taking your graph paper and you literally just cutting out 0, 1,000, what is it in 400? 0, 400, 800, 1,200, it's just cutting it out and scooting it down. So anytime you have a graph that doesn't start at 0, in fact, I would have even put one on that x-axis personally. I would have put one there. You put a little break in there to indicate that your scale's not starting at 0. So if I were doing this, I would even put a break right there on that axis. Okay, so that's what I would. The book didn't, but that's what I would do. Okay.
Would you put a 0?
No, there's no 0 there. No, it's like taking this graph and squishing it coming down and squishing it this way.
Yeah, I didn't know if it was 0 or symbol.
No, just means it's breaking at 0. Okay. As a student in public higher education, what questions about the average cost of tuition and fees at four-year colleges might you be interested in asking? So here's a trend through 2010, right? What might you be interested in? You're all students. You're probably going to be students for a little bit. What might you be interested in asking? Yes, Julia. Yeah. Yeah. What's the estimated cost to attend? Blah, 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 you know, fill it in the next 5 years. Absolutely. If you're trying to plan ahead, you're trying to figure out how many loans you're going to have and your debt and all that, sure. Now, this is U.S. public schools. Four-year public. It doesn't even deal with private. Okay, so that's another whole different bar graph. Okay, if we put the bars side by side with private, what do you think the bars would look like compared to these? Much, well, bigger in what way? The curve would be steeper and they'd be taller. Yeah, okay. All right. So the good news, it may be possible to answer your questions using mathematics. That's the good news. Okay, someone else want to read the rest of this for me? Because I'm already tired of listening to my voice. Eric's already gone. Okay, Brendan. Yeah, we can work.
Work with the real data collected and presented in the paragraph to find a mathematical model. Model is mathematical such as equations of the real world. Describe equations related. This is an important step in problem solving, being able to convert the description of a relationship.
So let's use mathematics to answer some questions about the cost of tuition using a model for the data. So here's a model for that data. So in other words, we took these figures in these years and we created a mathematical model. And this is the model. Does anybody remember what kind of equation this is? Quadratic. So we went with the curve versus the linear. We could have also made a linear model for this as well. So this formula models. There's no way to get exactly every single point. It's modeling it. We're trying to use it to estimate and predict the average cost of tuition and fees, which is T. So the variable T represents the cost. And here's where things get a little interesting. This may be new to some of you. X represents the years after the year 2000. So in other words, we'll never be putting in numbers like 2010, 2013. It's the years after. It makes your calculations a little bit easier because in this very first question, use this formula to find the average cost of tuition and fees. So we're trying to solve for T. We're going to try to solve for T for colleges ending in the year 2010. So we have to figure out what is the value of X? What's the value of X going to be? How many years after 2000 is the year 2010? 10 years, right. So X is 2010, take away 2000, which is just 10. That just makes our calculations a lot easier to do. So you go back up into your model, and where you see X, you replace it with 10, and you're going to square that, then multiply it by 4, and then you're going to say 341 times 10 plus 3194. So order of operations, that's 4 times 100 plus 3,410 plus 3,194. That's 400 plus 3410 plus 3194. And someone want to add that up for me on their calculator? Tell me what you get. Yep. 7,004. Do we have some agreement on that across the classroom? Sounds good to me. If I did this out yesterday. I think that's what it came out to be. Okay, so now when you go back to your graph, should you expect to see the top of the bar at 2010 say 7,004? Is that what this model does? Tells you exactly what the data was? It represents, it estimates, it predicts when you go out further. Right now, we're estimating what the tuition and fees are in 2010. And is this an overestimate or an underestimate if we go back and look at the real data back here? What was it in 2010? 7,020. So what is 7,004? Under or over that? Under. So this is a little bit under. It's an underestimate. And it's underestimating it by only 16 bucks, right? So it's not bad. It's pretty darn close. This model's doing a pretty good job. Okay, so now the question is what Julia was interested in. What happens 5 years from now? Is this trend going to continue in exactly the same way? One of our students, I can't remember who, said there was an increase after 2001 or 2. Is this going to increase? Is this going to get steeper or is it going to slow down? What's going to happen? So what I would like is I would like tables 1, 2, and 3 to get the answer for the average tuition in 2014, 1, 2, 3 right here. In tables 4 and 5, I'd like you to figure out what the average cost is going to be in the year 2050. Okay? And then we'll put them up. Okay? Someone from table 1, 2, or 3, other than Eric, who's pitched in quite a bit. We've heard from Logan. And remind me your name? Ian, okay. $8,752. Anybody from one of the other 2 tables get something close to that? Yeah? Okay, so that looks pretty good. What about 2050? We're going out now 37 years. What do we get for that? 30,244. Does that sound good? Yeah. Okay. So let's think about this prediction. Does that seem plausible that in 2050 it's going to be $30,000? Seems like a lot, but we don't know. Okay. If it seems really unreasonable to you, then sometimes we say a particular model has model breakdown, that it's really a good model for representing the data that exists, but if you go too far outside of it, it can break down. So you got to be really careful when you create these models, that you don't try to go too far beyond what your actual data is for prediction values, because you could run into problems. Makes no sense. Sometimes it doesn't make sense prior because it goes into the negative number. So you got to always be careful with when you're choosing a model, what you're actually using it for. All right, sets. I think a lot of you, I didn't say sex, I said sets. I know some of you woke right up when I said sets. Okay, so want to read this one for me, Nathan? Right. Someone else, number 5. Sitting next to Sonia's Tiffany, right? Yeah. Okay.
The objects in the set are called the objects. We rate a set by this form of set called roster.
Right. I like the rooster better, though. That's what in fact, I was going to say I'm going to call it the rooster method. You took my line from me. It's just funny. Roster, I think a rooster, but anyway. So the roster, think of a roster, right? I was calling your name off of a roster. You were all listed. Here's a set of people in this class. Here's the roster method where you list each member of the class, each member of the set. So, and I think the Three Stooges have come back in, so most student people now know the Three Stooges, Larry, Moe, and Curly. But notice the curly braces, that's the indication of a set. That's what's really important, is that anytime you represent a set, you must have, this is mandatory, okay, for every single set you write in this class, is that there's braces. There is one other notation we're going to learn later that will use something different than braces, but for now, set, you use braces, okay? So, at your seats, represent B. What is B? The set of the 7 dwarfs. So see if you can name the 7 dwarfs using the roster method. Let's see. Well, we got some pictures going on there. How do we start? What's the first thing we put after the equal sign? What kind of bracket? Curly. All right, that's not one of the members. All right. Okay, so let's go. What are they? Happy. Happy, you separate members. Happy, bashful. Oh, I know some of you forgot bashful. Yeah. Doc, sleepy, grumpy. What? Sneezy. How many we have there? 1, 2, 3, 4, 5, 6. What's the last? Huh? Dopey. Dopey. All right. All right. So that's called the roster method. Yeah, now for extra points, label each one. No, I'm teasing. All right. All right. Okay, so the next notation I want to introduce you to is this idea called set builder notation. You're going to have 2 main types of notation in this class, set builder and interval. Interval will come in a couple of classes. Set builder is a way to represent sets of numbers. Because sometimes when we solve an equation, the answer isn't just one number, it's an infinite set. It could be all the numbers less than 2, for example. So we'd have to have a way to represent that. So set builder notation is always set up like this. It starts with the curly brackets, braces. Usually this is an expression like x, whatever your variable is. Then you have this line right here, vertical line, that means such that. And then you have some kind of statement here that's true or false, something that you can read and test whether it's true or false. So for example, right here you notice, right on your paper, I have this statement. Okay, that represents a set. So if I was on my number line right now, like the real number line we just put in up on the board earlier, how might I represent the set right here on this number line? Well, first of all, you need to know how to read the set. So this says, this represents the set of all numbers called x, such that x is less than 0. So how would I represent it on the number line, Eric? Open circle, because I'm not including it. Yep. Yep, a line this way, right. Right, so this is how I would represent it graphically. And this is how I would represent it with set builder notation. And in English, we just call those set negative numbers, all negative real numbers. And don't forget, we have all those numbers in between here. It's not just -1, -2, -3. There's all the rational and irrational as well. Okay. Okay, union and intersections. Anybody recognize these guys here? Yeah, the Beatles. Thought long and hard about this section this summer. I did a little research and I found out that, I don't know, if anybody ever read the book Outliers? Yeah. You do? Isn't that amazing? Wow. And it's a great book. Yeah, Outliers, good. Malcolm Caldwell, right? Yeah. Right? And in there he talks about, you want to master something, it takes about 10,000 hours. Now, I know you don't have 10,000 hours to spend on Math 107 this semester, but you know, when he uses the Beatles as an example that there's sort of misfortune earlier on when they went to Germany and they played in these nightclubs night after night after night, actually honed their skills to having them master their musical abilities. So, but what a lot of people don't know is that we're going to let A represent the set of Beatles in 1961. And notice, these are the members of the Beatles in 1961. And some of you who may be music buffs knows what happened with Pete Best and Stuart Sutcliffe, and then how Ringo Starr really was probably the luckiest man in the world. The Fab Four that came to the United States in 1964, and oh my God, I remember the night they were on the Ed Sullivan Show. I was an itty bitty kid and we were all huddled around the TV. And I remember I was like maybe How old was I in 64? I'm not telling you. Anyway, I was 8. So anyway, I was thinking, I'm looking at they showed these girls who like, they're screaming and crying in the audience. It was like mania. It was unbelievable. So anyway, I don't know, just a memory, sorry to throw that in. But so I was thinking, how can I talk about union and intersection in a way that might keep you interested? See, I'm always interested in keeping you interested. So we're going to imagine that there's going to be a Beatle reunion. Wouldn't that be nice? Assuming all these people are still alive. Okay? So now I want to list, using the roster method, who would be part of this reunion. So you want to help me out? We'll just do the first names, okay? Who would be part of this reunion if C is that set? John, Karis, what else? Paul, okay. Trying to get someone else, Sonia? George would be there, yeah. Whoever. No, I'm from Boston. I know that's my accent. Sorry, it's never going to leave. Haley? Who else? Stuart, yep. Pete? Anybody else? 1, 2, 3, 4, 5. Who would be at that reunion? Ringo. All right. Is that everybody? Okay. So notice what I did. This is a little, now I'm going to ask anybody reading Moonwalking with Einstein? It's a memory book. That's another one you might be interested in. The set of reunion members. Reunion. Notice what I did? Union, right? That's a little memory. How do you remember union? Think about a reunion. Represents the union of two sets. This is the mathematical way to do it with a U. It's read set A or set B. So if you're listing the members for the reunion, we don't have enough time. I would have wanted you to write your own idea here, but how do you represent the union or the reunion? What do you include in the set? How would you say it? Everything. Everything. What does that mean? Everything what? We got two sets here, A and B. So how would you all the given data, all members of set A or set B. Do you repeat them? Right, minus what they have in common, right? So you say all members, you list all the members of set A, and then set B is you throw anybody who's not in set A, but all the people in A are in B except for one guy, right? Ringo. So you don't repeat it twice. All right. What about let D represent the set made up of members of both bands. So what members are in both of these bands? What members are in both of them? John, Paul, and George, right. So we call that the intersection, and that's denoted by this little symbol right here. And that's what those are the members that both bands have in common, right? They both have John, Paul, and George, okay? So that's intersection and union. Your book will give you examples with numbers. I just thought the Beatles would be more fun. Okay. All right. This is where we started class, absolute value, right? Absolute value of X equals, notice, it's two statements. The definition is two statements, two different conditions. Look. There's the first definition of X for this set of numbers. That's to the right side, 0 and to the right. And here's the second definition for all the negative numbers. So I want you to take a few minutes, and we only have 6 minutes, and review this definition and discuss it with a neighbor or two. And here's the question I want you to answer. Does this definition mean the absolute value can be negative? Looks like it to me. Why or why not? So look it over and have a discussion about that.